Hi everybody. In this video, I'm going to take you through an exam question on solving fractional inequalities. So we need to determine the set of values for x, for which x minus 5 is less than 9 over x plus 3. The problem we have with questions like this is that this x plus 3 could be a positive or a negative, and if you multiply both sides by the negative, we'd have to change the sign. But if this is a positive, we wouldn't have to change the sign. So what we need is something that will cancel with this x plus 3, and we know must be a positive. So the way we get around this is we multiply both sides by the x plus 3 squared. Because what will happen is this squared will cancel with this division. So on the right hand side, we'll get 9 multiplied by x plus 3. And now we can move this over to the left hand side by subtracting it from both. So these two will cancel, and we'll get this on the left hand side. At this point, we can factor out the x plus 3. So what we're left with is one of these x plus 3's and the x minus 5, and the negative 9 from this term. And now we can simplify this by expanding out these two brackets and collecting the constants. So we get x squared minus the 2x minus the 24. And this will factorize into x plus 4 and x minus 6. And now we can sketch this cubic using these roots, and we'll identify where it falls below the x-axis. So the roots will be at this point, negative 4, negative 3, and positive 6. Now we're looking at where the curve is below the x-axis because it has to be less than 0. So this will be here and between the negative 3 and the positive 6. So using set notation, our solutions, x will be less than the negative 4 or less than positive 6 but greater than negative 3. So that's the answer for part A. For part B, we can use what we've done here to solve the inequality when we're dividing by the modulus of x plus 3. If we go back to the start, we had to multiply both sides by the x plus 3 squared, because this denominator could have been a positive or a negative, but now we're told it must be in the positive because it's a modulus. And if it's a positive, we can multiply both sides by the x plus 3, and we don't need to change the sign. So we've moved the x plus 3 over to the left-hand side. We'll take away the 9, and when we take away the 9, we get exactly what we did here. So all we need to do is to consider the solutions arising from this quadratic, which are the x squared minus 2x minus 24. So our solutions, when this is positive, would be from positive 6 to negative 3. So the answer for part B is that x must be less than the 6, but greater than the negative 3. Okay?